This filter capacitor shell is ready for restuffing. There are no markings on it except for a plus sign for the positive terminal, but it's an 8 microfarad 450 volt capacitor that goes in it. I'll be putting in a 10 microfarad 450 volt capacitor. I soldered a stranded wire to the positive lead of the filter capacitor so I can solder these leads to the terminals on the shell and then stuff the capacitor in. It looked like it was going to be too hard to do that if I use a solid wire that came out of the filter capacitor. I decided to stuff this shell with cotton instead of filling it up with wax. Since it's inside the radio chassis, it doesn't have the possibility of getting crushed or anything like that. The shell's been restuffed with a 10 microfarad capacitor. Since there's no markings on here, I'm going to write the value of the capacitor that was supposed to be in there originally. I guess you could say this cup is stuffed full, and it's also full of stuffed capacitors. Just finished marking the capacitor. I guess I should have printed something off and glued it on there, but this can easily be removed with some solvents. It's just Sharpie. This filter capacitor was a little bit more difficult to remove from its shell. And what's interesting, they use cheesecloth as stuffing inside of the shell, so I don't feel too bad using cotton. I'll be drilling holes underneath the terminals to run the wire from the new capacitor out. Holes are drilled to run the leads through for the new cap to connect to the terminals of the shell. Leads are installed on the capacitor, ready to stuff into the shell and terminate to the terminals. This capacitor is restuffed. Wire leads terminated to the terminals. You can see the wires coming out of the holes. What's in the radio, it'll look like this, and the terminals will block the wires. The components have been removed from these filter capacitors, ready for restuffing. This resistor should measure 2500 ohms. Measures almost 4000 ohms. I'll be adding a resistor in parallel to get it down close to 2500 ohms and hiding the resistor under the dog bone so you don't see it. A resistor was added in parallel across this 2500 ohm dog bone to try to get the equivalent of 2500 ohms. Came out to 2640 ohms, which are 2640 ohms, which was good enough for me. This dog bone resistor should be 4000 ohms, measures 6730 ohms, so we'll add a resistor in parallel to try to get it back down to 4000 ohms. Added a resistor in parallel to get an equivalent of 4250 ohms, should be 4000 ohms. New filter cap has been stuffed inside of the old shell, and the 2500 ohm resistor has been reinstalled between the terminals with the parallel resistor hidden underneath to give you the 2500 ohms, or actually 2600 ohms. All the guts have been removed from this shell in preparation for restuffing. This cap is ready to be restuffed inside the shell. Capacitor placed inside the shell, terminals coming out, ready for termination on the terminals of the shell. I removed the coil shield from this coil here next to the 6A7. I'll inspect it to see if the windings are okay. I believe that this winding here might be open. The The shield was a little tight getting it off, so I used my reamer here to, there it is, use the reamer here to make the holes a little bit larger for the screws coming through the top where the nuts screw on. And it does look like there's enough room to unsolder the leads going to the coil and remove it here from the top side. See how it goes in a little bit. But first we'll draw a picture of all the wires connecting to the terminals of the coil. I thought this was a spider web in the middle of the coil, but it looks like it's just some cotton that was stuffed in here. Here's the wad of cotton removed from the coil. I like to use nail polish to mark the leads and terminals of coils and other components, speakers, things like that, so I can identify which wires land where. This coil's been removed. All of the leads are marked with nail polish. Here's the coil with all the terminals marked, correspond with the wires that land at these terminals. In the process, removing the coil shields. Had to move these trimmers out of the way so I could get to the nuts to remove the shields. One of them here, hard to see, there's a microcapacitor that's got to be moved out of the way. Also, this coil right here has got an open winding, so I'm going to be removing that to rewind the open winding. And some capacitors here that need to be restuffed, buried down near the band switch. So far, 2 shields have been removed. It took great effort, but I removed these 2 25 picofarad mica capacitors. They were blocking access to that nut right there in the middle of the screen. And with this nut removed, on the top side of the chassis here, finally we're able to remove the last shield over the coils. Got the oscillator coil removed. 3 coils are still in the chassis. If they're good, I'll leave them in place. Just wanted to remove the shields and inspect the coils. Again, all the shields are removed to expose the coils. I taped off these shields that were on top of the shield coils just to keep them from flopping out of the way. They're connected to the tuner with braided flat wire. I decided not to unsolder it and just tape these shields in place. Again, we'll inspect each coil. Just looking at them, it looks like there's no copper oxidation. I don't see any green anywhere. We'll check the continuity again, see if there's any issues with these coils. Here are the resistance readings of the antenna coil. And here's the antenna coil in the radio. Didn't remove it because it checks out okay. I coated the coils to seal out any moisture. Rust remover has been applied to rusty parts of the chassis. Looks like mice had urinated under the RF black shield around the tuner here, especially on this side. See how the rust remover does it, removing all this rust from the mice. The band switch was cleaned by first soaking each section in ammonia, letting that sit for about 15 minutes, and then soaking this brush with ammonia and scrubbing each of the sections. And then following that, cleaning each of the sections with contact cleaner, and then after that, spraying a little deoxid on each of the sections. So now, it's probably hard to see. Got a light in here. Each of the sections are pretty clean. This wire on the left was removed as it was behind one of the sections of the band switch, and I couldn't get to the contacts to clean them. So I removed that wire and added a piece of cloth covered wire that was a bit longer, and then I'll reinstall that into the radio here. See if I can point at the terminals it goes to. So that short wire was connected to this terminal, routing behind the wafer, or the section here, over to this terminal down here. Oh, there we go, this terminal down here. So I'm going to route the wire over the top to go down to that terminal, so I have room to get into this section here and clean it well. This is the plate switching, or the coils that were switching to the plate of the 66 tube that was only working in one of the bands. So I'm hoping that cleaning this section will allow continuity to the plate. The plate coil was fine, but this section, I think it just was dirty. This wire here was also routed behind the band switch section, B+ section, and I'm going to route that on this side, kind of following this, getting a picture here, following this red wire going to its terminal right here. Now I got total access to this plate section of the band switch, so I can make sure it's really cleaned. Inspecting it, it looks like when I squirted the ammonia in there and brushed it and sprayed it with contact cleaner, cleaned it pretty well, but I'm going to go ahead and clean it again. This plate coil had both windings open. Maybe hard to see, but this one winding on the first coil on the left was disconnected from the terminal, so that's an easy fix. The middle coil had this lead coming out there, going to its terminal, but the lead on the outside was broken off where it connects to the outside coil, and the outside coil has its lead on the inside of the coil connected to its terminal. So the two outside leads of the middle and outer right coil connect together. So I'll find the lead on the outside coil on the right and connect the two together. I've located the other lead from the outside coil on the right, and then those two leads will connect together to make the repair, and then also resolder that one lead to its terminal. All the leads have been connected to terminals, and the middle and outside right coil leads connected, and I've got continuity on all four terminals now. Wax has been melted over each of the coils to provide insulation from climate moisture.